Hello everyone, my name is Narsimha and I'm pursuing my BTech at Institute of Aeronautical Engineering College, Hyderabad, in the stream of Computer Science and Engineering with a specialization of Data Science. So today, as a part of my AIT Tech Talk videos in the subject of disaster management, I want to explain about a topic named Evaluating Process-Based Integrated Assessment Models of Climate Change Mitigation. Actually, this is a title of IEEE paper which was published in the year 2021 by these three authors. And you can see the citation of this paper here at down. So coming to the main abstract, means the main motto for writing this paper is the study means the paper is focuses on the evaluation of process-based integrated assessment models, IAMs, shortly abbreviated as, which project long-term transformation pathways in energy and land use systems under various assumptions related to climate change mitigation. The study provides the first comprehensive synthesis of process-based IAM evaluations research, drawing on examples from 6 different evaluation methods, including historical simulations, stylized facts, and model diagnostics. First of all, what is this integrated assessment models? Where will be using it? And what is the application of it? That will be known. So, first of all, come to the integrated assessment models. What are they? IAMs are the tools used in interdisciplinary research to analyze complex systems and assess the interactions between different components, often focusing on societal, economic, and environmental factors. These models integrate insights from various disciplines such as economics, energy systems, climate science, and policy analysis. The primary purpose of IAMs is to provide a comprehensive framework for decision makers to evaluate the long-term impacts of different policies, particularly in the context of global issues like climate change. For example, let's take a real daily life example, that is, at night we will get the weather report. Means at the night we will get the weather report of 2 to 3 months of further future. Like it will be rainy or it will be sunny, and the temperature will be high and it will be 40 degrees or it will be moderate, etc. Anything. So the main declaration of the future weather will be declared by some of the parameters, like how it is the climate, global climate at present. This is a complex data structure. So by analyzing this complex data structure, we need a framework, means we need a summary of that present weather report for predicting the future. So these complex data structure, complex systems are analyzed and the summary is given by this framework, that is integrated assessment models. So coming to the, for each method, which I said before, there are 6 methods used in this study. For each method, the research identifies progress, milestones achieved, lessons learned, and challenges remain. The findings indicate that each evaluation method has unique strengths and limitations. Additionally, the research suggests a program of evaluation to be integrated both within and outside the IAM community, aiming to enhance the model's utility in the complex domain of climate change mitigation. So coming to the key factors of IAM means on which parameters this IAM will be declaring the final result. That is interdisciplinary nature, long-term analysis, scenario analysis, policy evaluation, trade-offs and scenarios, and uncertainty analysis, global perspective. These integrated assessment models have been widely used in the study of climate change mitigation, energy policy, and sustainable development. Coming to the methods for evaluating process-based IAMs. What are the different methods? There are 4 methods, that is historical simulations, stylized facts, model diagnostics, and systematic evaluation framework. So coming to the each method. So I am giving the description of the each method and also the purpose of using the method. So coming to the historical simulations. These historical simulations involve comparing model outputs with actual historical data. This method assesses how well the IAM reproduce past events and trends, providing insights into its ability to represent real-world dynamics. So, for example, let's take an example of machine learning algorithm like clustering, like KNN, or means anything. After the training of the model with the dataset, we will test the model and we will compare the outputs, means the obtained outputs with the real outputs. If both are matching, then we can declare that model is the very accurate model which can be giving the accurate results. If in the comparison, the predicted outputs and the actual outputs are different, which are not similar for the up to maximum extent, then we can declare that the model is not accurate and it should be trained with more data sets, or it should be trimmed with the least parameters for the training. So in the same with this historical simulations, will also will be working method. And the purpose of using this method is it helps validate the model's historical accuracy and serves as a benchmark for evaluating its predictive capabilities. Next, second one, stylish defects. What is the description of this? Stylish defects refer to the specific patterns or regularities observed in real world data. In the context of IAM evaluation, researchers assess whether the model can reproduce the stylish facts, which are essential characteristics of the system being modeled. First of all, what is the stylish facts? It is the specific patterns or regularities observed in real world data. For example, in India, you can see there is more in the rainy season, and in America, means in abroad countries, you can see that it is very frequently there is a snowfall. Means that stylish facts should be declared. In India, we cannot see frequently the snowfall. In the same way, in America, we cannot frequently see the rainfall. It is a snowfall. So these are the stylish facts, and we can access the model whether it is providing the stylish facts or not. So the purpose of using these stylish facts is evaluating IAMs against stylish facts helps ensure that the model captures key features and behaviors of the systems they represent. This is the main feature, the key features, whether the model is able to accepting the key features and delivering the key features or not can be declared by using this stylish facts method. Third one, model diagnostics. Model diagnostics involve a detailed examination of the internal working and outputs of the IAM. This includes assessing the model structure, parameters, and assumptions, as well as comparing its outputs with expectations based on scientific knowledge. After the model has been giving the outputs, we can compare the outputs with the actual outputs. Otherwise, we can compare the outputs with the expectation outputs of the creator of the model. So if the predicted outputs are up to the mark of the expectations of the creator, then we can say this model is accurate. And the purpose of using this method is model diagnostics help identify weaknesses, errors, or areas for improvement in the IAM and contributing to model refinement and increased confidence in its results. Fourth one, the last one, systematic evaluation framework. The systematic evaluation framework combines multiple evaluation methods into an organized and comprehensive approach. It involves assessing the appropriateness, interpretability, credibility, and relevance of the process-based IAMs. It acts as a mixture of different models. By combining the pros means the advantage of different models, we can use the systematic evaluation model framework. The purpose of using this is it aims to provide a well-rounded assessment of IAMs, considering various dimensions of their utility as scientific tools for informing climate policy. It offers a structured way to synthesize insights from different evaluation methods. Coming to the proposed methodology of the authors in this study, that is, each evaluation method contributes to the testing of IAMs against one or more of the four evaluation criteria that are given these four parameters. Based on these parameters, the evaluation methods are giving the accuracy of the model. So in the same way, IAMs vary widely in the resolution of mitigation measures, policy options, and spatial scales. So evaluating IAMs against the appropriateness criterion helps establish the resolution adherency of a model for given a task. So for example, near-term observations that diverge from historical model projections may reveal influential process omitted from model representations. So coming to the MIPs, that is model intercomparison projects, or diagnostic experiments involving models with different technological process and spatial resolutions are useful for identifying the influence of resolution on the outcomes being explored in the MIP. So based on the outcomes being explored by this method, that is model intercomparison projects, we can declare the resolution, means whether the model IAM model is accurate for using the declaration of the climate policy or not. So also this MIPs also contribute to the interpretability of the IAMs by linking model behavior and resulting policy insights to structural representations of energy, land use, and economic process. So this evaluation method should similarly help strengthen the relevance of IAMs for advancing understanding of emission pathways and policy response. How? Over the longer term, both MIPs and sensitivity analysis help improve IAM's ability to identify robust alternatives for achieving defined policy goals such as 2 degrees centigrade climate satisfaction, etc. And next, main objective. What is the main objective for doing research, for doing this study is, the objective is to establish a significant medium to long-term research and practice program for IAM evaluation, such as these community-wide activities are proposed to drive and coordinate this program with specific near-term high-value activities outlined, such as automating diagnostic indicator calculation, community protocols for global sensitivity analysis, and publishing community libraries of historical data, strengthening empirical social science integration. So these four parameters should be achieved by using this algorithm proposed by the authors in this paper, means in this study. This is the main objective for writing this study. So coming to the one by one, automating diagnostic indicator calculation. What is this? The main aim of this model is parameter is lower the threshold for diagnosis new IIMs and community protocols for global sensitivity analysis. The main aim is to increase the frequency and comparability of the uncertainty analysis. The main approach of this automating diagnostic indicator calculation is automate the calculation of diagnostic indicators in scenario databases, making it easier to fingerprint and access new generations of AI. Third, publishing community libraries first of historical data means minimize your unnecessary variations in MIPs due to base year differences. Means the collection of the data of the historical data should be stored, by which the model training will be very much useful for the databases, and strengthening empirical social science integration. The main aim is evaluate the impact of human decision making on model outcomes. So coming to the conclusion of the study. Finally, I conclude that is evaluating IAMs helps establish the legitimacy of their use, the appropriateness and adequacy of their application, and confidence in the results among users. With the growing prominence of global IAMs in international and national climate policy, the time is ripe for establishing a model systematic approach to IAM evaluation, combining multiple methods in an ongoing collaborative process involving both modelers and users. So thank you, friends. I hope my lecture is useful for you. Thanks for watching. Thank you.